There we go. Now this data set, because I aggregated it up to a very high level, which I explained in the description for the data set, it only has a couple of things that are classified as watersheds. So forgive me, there's only a little bit of green here. But if I zoom into this area in the center of the map, I have some areas that have green, many areas that have turquoise, which are like wetlands, and a lot of area which is the bay, and channels and rivers and stuff like that. So you should see, if you did it right, and if you didn't, we can all come help. You should see 3 colors based on the different filters and the rules that you set. We just had a participant, he added 2 rules that had a filter and a final rule that had no filter. And what Google Maps Engine does is, first it applies the rules, and then everything else left over, it assigns to that final display rule. So what that means is, if you have 1 or 2 locations that you want to call out with a color, and then everything else should be red, just don't apply a filter to that final one. And that's how you would get that. You wouldn't have to know every single class for the remaining. It will just pick out just the one. So that's useful to know. But right now, for my map, I did 3 filters, and each one of, or 3 display rules, and each one of them has a filter. Okay. Any questions? Can someone help? Dave, do you want to help me? Thanks. Thank you. Okay, the final thing we're going to do to this map is we're going to manipulate the info windows. So you notice here we've been working in styles, in the styles tab, but I'm going to click on info windows right here. And so click on info window, and you're starting to see patterns here. Like Fusion Tables, when you went in and to change the info window, it gave you a default HTML code that you could then edit if you wanted to. And I can do that. I can edit this and add text. But what I would like to do is make it so that anything that is an image, these 2, actually show up as images. So I need to add HTML around that to tell it that it's an image. But don't worry, I've done all the work for you. This is the info window balloon HTML that you need to copy and paste in. And if we look at the differences here, those of you who are not familiar with HTML may get a little more comfortable with it right now. So I'm going to scroll down so I can point. No, okay. So this is the previous one. This is the default. And this is the one I just copied in. And the difference is you can see here. So the first thing I did was I wanted to add image source equals image 1 and give that image a width of 200 pixels. Before, it just had, okay, bold title and the URL spelled out. But that's not useful. What's useful is adding the image source around it so that it reads it as an image on the web. And I did the same thing for image 2, and then you'll notice that I have a URL, and I basically added an href, which is a hyperlink reference that references this URL, and the text that I want to be linkable is called read more, ... So I did this so that it would then, everything would then be already displayed correctly in the bulletin. So let me show you what this looked like before. That's what it looks like before I apply it. And then if I replace it with my new code and click apply, while this is updating, you have to know that you cannot accidentally put an equal sign in the wrong place or a quote, because it will just not work. So make sure if you get an error that it's maybe because you changed a tiny thing. I mean, that's how HTML works. It's very particular. So if you ever have any problems with it, recheck your code or ask somebody who might know. So if I click now on the bays and channels, and I wait a moment, because the internet needs to catch up. While this is loading, you can see I already have a hyperlink here to read more, and this goes to the data source. So I wanted people to say read more and find out about this data set. I also wanted people to know exactly who the data source was on Wikimedia so that they would be credited. But I see.
I have a question while you're waiting.
Yeah.
For an audience. How does Maxigen deal with different projections?
How does it deal with different projections? That's a great question. It automatically reprojects it on the fly, as long as you have a .prj file. Does that make sense? So we went over those 4 different PRJ or 4 different shapefiles, and one of them was a PRJ, so you must have that one. There it is, okay. Come on, it should be enough. Anyways, hopefully the other one will load soon. If not, it might be because Wikimedia took it down. I have to check that. I just tested it last week, so I assume they're always up. But so this is one of my pictures. I have 2, because you remember, image 1, image 2. Image 1, and then the source, image 2, and then the source. So only image 1 is showing right now, but if you have your own pictures, you'll of course always keep them live and up to date. But that's the little salt marsh harvest mouse. He's endangered, and he's definitely the favorite of everybody who lives in the bay and loves the wetlands. And so I want, so in that, in all the rows and all of the data attributes that are for baylands, I have this URL. But if I go over to the watershed, I have a different URL. I have a picture of a watershed. And I wish, there we go, bays and channels. So then this is showing a bay and channel. And there's another photo that will hopefully eventually load about showing the bay with the Golden Gate Bridge and an egret. So my whole point of showing you this is that as long as your data is set up properly with the different attributes, with the different URLs, it's really easy then to just feed it right into the balloon, and then all of your polygons or points will automatically have different photos because it's already set up. But that means, that's my final lesson to depart you with, is that sometimes your data needs preparation. Go. Start a current slide. So many times you're going to make sure that you have the proper projection. So we had a question about projection. You need to have the proper projection. If you don't, it won't be displayed. It will get reprojected on the fly, but it will use the wrong algorithm. Like if you have the projection, if you have Kenya data and it's somebody applied Uganda projection to it, it's not going to be correct when it overlays. You have to make sure that it's not only labeled with a projection, but it's labeled correctly. And then sometimes you just have so many vertices, I'm talking millions, and it may be too complicated to show, and you might have some data processing issues, and so there are ways to reduce the vertices if you have too many. And then sometimes, if you're a GIS professional, you know this, you may know this, sometimes you have polygons that are separate, but they're part of the same row and same feature, it's best to separate them into single polygons. And sometimes data, we all know GIS data can sometimes come with topology problems and invalid geometry. You got to fix those before, unfortunately, in something like ArcGIS or ArcMap. And then sometimes special characters, they're fixing this actively, so this may never be a problem, but if you ever have processing issues, especially with your balloons, and your balloons aren't showing and you know you did it correctly, it may be because it doesn't know special characters, but they're fixing that, and they're supporting all those 50 languages. That's the aim, and so definitely good to remember. So I'm not going to show you guys this, but I wanted to just show you, I'm going to exit. Oh, I didn't apply, did I? Yes, I did, good. I'm going to click exit, I'm going to click publish layer, and what you guys can do at lunch after Dave gives the introduction is I've shared with you, in addition, just make sure you're shared.
You shared with map editors.
I shared it with IUCN editors now. Yeah. So so I shared with you a topography mosaic of the San Francisco Bay Area, and this is an image that I imported, and so I shared it with you guys, both the data set and the layer. And so your homework over lunch or tonight when you get home, when you get back to your hotel room, is to create a new map with this on the bottom and the baylands that we just styled on top. Okay, a little extra work. And email it to me if you finish it, and if you want, and that would make me really excited if you did that. I'll put my email at the bottom of the exercise list here. Okay, and don't forget, if you want to learn more, there are tutorials. You can read a case study and a story about WWF. They're going to be talking about it later this afternoon. They use this tool, and I don't know, I think he loves it. So Michael's told me he does. So it's working for them because they have so much data, and you'll see what we mean in a moment, a little later. And then of course you can apply for a grant here. But just to show you the tutorials, just to prove to you, I'm going to show you the styling, because that may have been a little bit fast for some of you. If I scroll down, creating the layer, adding it, there's the red baylands we saw. Here are the different style editor, or style display rules, copying and pasting. Here's the code. Everything is online. And this is what it should look like, so I'm going to check those links. And of course, then you can publish it and create a map and go on to the next tutorial. So it's all there for you later on. Okay, with that, I will step down at 12:30 on schedule. And I know you guys are probably fried, so Dave is just going to introduce the tool, and then we're going to break for lunch in half hour. So hopefully, right now there's no hands-on. It's just sit back and enjoy Dave's presentation, and then we'll have lunch and refuel before the next hands-on.
Thank you, Karen.
Thank you.
I'm Dave Thao. I'm the developer advocate on the Google Earth Engine project. And that means it's my job to work with nonprofits and government organizations and NGOs to develop platforms and algorithms that run on the Earth Engine platform. And Earth Engine is our geoanalysis platform. And if you want to write me, you can always write me, thao@google.com. So this is Google Earth, and you're now all familiar with Google Earth, Dr. Brawley's excellent presentation, or from before then. And it's, so as you know, it's a really great tool for visualizing geodata. There's lots of good satellite data and layers in there, and you can share polygons and that kind of thing. But the one thing it was not designed for was actually analyzing data. So if you wanted to do some kind of analysis on the data, like figure out what's forced and what's not automatically or something like that, Google Earth isn't the place to do that. And as we go around talking about Google Earth, we got a lot of feedback from people saying, Google, you have a lot of data and you have a lot of computers, can you help us actually analyze the data? And so we listened and came up with this thing. So what do I mean by analysis? There are a couple of different things. I'll give you some examples first. So a while ago, we were approached by a member of the European Parliament to create a roadless area network map. So this is a good conservation example. The idea is if you want to conserve areas, first you have to know where the sort of pristine areas are. And a good way to do that is to find out where there are no roads. And at Google, we have a big database of roads. And so we seem like a natural group to generate a map of where there are no roads. And we did that with Earth Engine. It was fun. And you can, I'll show you in the hands-on, we'll go through the site where you can navigate around this. But this is an example of the site. You can see where the colors are lighter is where there are roads, and there's a buffer around the roads of, I think this is 1 kilometer, yeah. 100 meters, 1 kilometer. And this is actually interesting because you can see here there are these funny areas where there are roads, but they're not connected to anything. And those are places where there's usually a landing strip for like a mine or something like that. And if you zoom in, you get surprising results. So this is Alaska, and I always thought Alaska, that place, it's got this pristine wilderness, but you can see there's not a lot of area in Alaska that isn't near a road. So this is one kind of analysis. It's take the roads and do a buffer around them and then present it. Another kind of analysis is deforestation detection. So we're working with a group called Amazon who does deforestation detection in the Amazon. And they publish a monthly report on what deforestation has happened in the Brazilian Amazon. And they had a desktop system that they were using to do it, and it took them about a month to process a month's worth of data. And their hope was to expand beyond the Brazilian Amazon, but they were constrained. So we worked with them to port their system over to run Earth Engine. And here's some examples of it. So this is they have a validation tool. So the way their process works is they have an algorithm for detecting deforestation. It runs on satellite imagery, and then it comes up with predictions of where deforestation happened. And then they have experts who go through and they validate the algorithm to make sure that it's right everywhere. So their validator will go to this tool, and they'll choose a cell in the Amazon, and they get a result that looks like this, where red is where the algorithm said there's deforestation, yellow is where it said there's degradation, and green is where there's existing forest. And places where there's no green are places where forest has already been cut down. And the validator will go through and say, yes, this is correctly detected as deforestation. And they can bring in different information to help with their validation. And at the end, that goes into a report. And so in this kind of report, you can see where degradation was detected and where deforestation happened. So this is an example of a group outside of Google using Earth Engine to develop software that does analysis based on their own algorithms. So if you look at the site, there's a little bit of a Google thing up on the top here, but it's an Amazon site, and they're using Earth Engine to do the analysis. Another thing that we can do is analyze data over time. So let me run this so you can see what it looks like. Here's the Earth Engine site. On the bottom, there are examples of things that people have done with it. And here is this map of change over time, and it's a map that you can zoom into spatially, and you can look at over time. So over here, it's kind of looping over time. You can slow it down a little bit. You can zoom in. It's an area that you're interested in, and you can see as the time progresses, it's a little bit dark, as in better images, but you can see this part of the Brazilian forest getting cut down. So here, it's tough to see here. But the way we built this was by analyzing 10 years worth of satellite imagery. Let me show you a better picture of what it looks like.